the afternoon. I'm sorry that you still have to listen to me, but this is a last-minute resilience approach. And sorry that I changed myself, but I allowed to have a little bit of Zoom. So this afternoon we are going on with the service-oriented architecture and smart stars. So we will discuss about what does it mean to have a smartness, and we start with the Guadalupe that is working on this stuff since long years, and we also know Guadalupe from the IoT of the past, I would say, yes. So it's a long-standing tradition, and she will talk about context-aware collaborative IoT services for smart everything. After the break, we'll have Javier that will speak about smart computing continuous for smart environment. And I will stay attention that you don't get asleep.
Thank you.
I stay there and give you the message.
So, thank you for the introduction, Massimo. I will first of all introduce where my university is, right? Because some of you already asked. Many people get wrong and listen to Cádiz and they think about Cardiff in UK. So no, Cádiz is also near some part of UK. It's near Gibraltar, but in fact it's in the very south of Spain. In particular, to put you in context of the research that we are currently doing at the university, because sometimes it's focused on the enterprises of what we have around. Cádiz is the oldest inhabited city in Europe, and its economic activities mainly focus on tourism, right? There's some naval and aeronautic industry around there, but mainly it's tourism.
So is it elder than Prague?
Excuse me?
You said the eldest university?
No. The eldest city.
City, I saw that.
No. And in particular, it is the province in Spain with the highest unemployment rate, currently 25%. But it is a nice city, you know. We have 4 campuses. One of them is in the city of Cádiz, so you're always welcome to visit there. This is my research group. Now we have a few more members in the group, but the photo is not updated. And the main focus of the group is on the one hand on testing and validation. And some of us, mainly 5 of us, work on the topics that we are presenting today, right? 3 out of these 5 are currently present in the room. And these are some of the projects that we are running currently. And we are mainly focused on this presentation on these projects, on the session I produced on a center, which are mainly related with applications for smart cities or for smart environments.
Look, are these EU projects?
Excuse me?
Are these EU projects?
No, they are national projects or regional projects, mainly national. We are looking forward to proposal for EU projects.
Absolutely. That's why I'm asking.
Okay. So let's introduce some concepts before we get into the matter of the project. We could talk about Internet of Things, but even though we have a very usual known definition of Internet of Things, I would like you to pay more attention to the things that have encompassed the last year Internet of Things. Of course, we have the availability of the internet 24 hours a day, 7 days a week. And we have all this fall in the communication costs. So this has provided a chance to make really use of the Internet of Things data. The democratization of devices with powerful, also for internet connection, has been really key in this domain. The strong proliferation of sensors, of course, according to all these facts, but the most important thing, I think, is the desperate hunger for data consumption, right? So the society seems to be desperate to get data about everything in all levels, not only the enterprises that are making money with data, but also the citizens are looking forward to have more and more data of anything and to make something with such data. And besides, we especially pay attention to the concept of the collaborative Internet of Things, mainly in the different levels of collaboration. It's not only a collaboration between the different businesses, administration, individuals, scientifics, and so on, but it's also a question of collaboration between data, so getting data in order to mix from different domains, so the collaboration from different domain stakeholders. And finally, also the collaboration in the sense of sharing data and knowledge between not only the sensors and the cloud, but also the intermediate situation of interest detected along. So I have introduced some comments around from which some people already said here around these days. Sorry that I didn't introduce sentences from everybody, right? All the presentations were very nice, but some of them brought my attention, like the comment from Harald that said that we need a framework for collaboration. And I completely agree, and this is the main issue that we will see in this presentation. So another question is, of course, we have this collaborative Internet of Things, but we have to bear in mind that everything is smart. And we mean that everything is smart because, of course, all of us here have smartphones that are already taking a lot of data and providing smart decisions. We have probably, most of us, something that makes our houses smart. We have been discussing also about the smart energy. We could discuss about the smart health, and at the end what we have is a lot of smart data which we can use in different domains and applications. So the requirements that we think, the basic requirements that we think that are necessary to have context-aware smart cities or smart environments or smart everything is having full access to the Internet of Things and the collaborative Internet of Things, and having a powerful way to process data. And our final aim with all these projects is to provide an improved quality of life and living experience to the citizens, to have contextualized and personalized experiences, and beyond all that, to have sustainable cities. And that's all, it was already previously said here in SummerSOC, not only sustainable in the scope of the environment, but sustainable in many other ways or domains, such as the Sustainable Development Goals. And when we talk about context and context awareness, we can find a lot of definitions from many years ago. At the end, what we want to know is what is exactly context. Most of people do not agree, and they don't agree because it's difficult to have a unique definition. So the context can be something completely different in different domains, different situations, different scopes, or for the necessity of different applications. So it can be anything. It can be where you are, who you are with, which is the temperature, and so on and so forth. We can take into account many things that can be context, so anything that is around or is related to the application that we are developing and that can be useful to improve the decisions of such application will be our context. Of course, mobile phones use context in many time, not so many, but enough time ago. And Google permits programming a lot. It's from many years ago too. But I wonder if really the service research community providing facilities to deal with context. I know some of you, and me of course, did some research on this topic from context awareness, but lastly, I couldn't find so much interest on this. And however, I still think that it deserves to have research on this. Also mentioned here by Ella Peltonen, she mentioned like the context for car driving, like traffic, weather, road, environment. But I think we are missing a lot of more context that it doesn't have to be exactly related with the domain which the application is developed for. If we talk about the technologies, we are going to talk about the technologies that we have used in our research group in order to deal with context awareness in smart environments. Of course, we could talk about service-oriented computing, about web services or REST services, and not go to obviously to describe what they are because we all know. We can discuss if we should go for a more classic service-oriented definition or REST service one. In our application, in our architectures, we use both approaches. But we also use event-driven architecture, and in particular, event-driven service-oriented architecture and complex event processing. So for those of you who are not familiar with event-driven architecture, you just have to have in mind that an event is anything that happens, or maybe that doesn't happen if you are expecting something to happen. And what event-driven architecture provides us is a particular style of software components which are decoupled, completely decoupled, and when something happens, then you receive a notification or you receive a message. And it's based in the publish-subscribe mechanism opposed to the service-oriented computing that is based on the request-response mechanism. But if we can, of course, any of such data that we have around, any of this data provided by the Internet of Things or another sources, can be considered as events, because it's something that is happening. It's a measure that is taken in a particular moment. And this is what we consider as events in our event-driven architectures. And what we thought is that we could combine both type of architecture and having event-driven service-oriented architecture, also known as SOA 2.0. And what we have is that communication between users and services can be based on event-driven. So event-driven communication will permit a faster response to what is happening, and maybe when we detect a few events happening around, that may be something from the Internet of Things, something from our context, in that case, we can trigger some of our services, or we can just personalize the response that our services are giving.
Look, will you discuss, if you go back please, the second bullet? No, sorry.
Oh, so the second bullet,
The second bullet, real-time intervent to faster response, will you prove it?
Excuse me?
Will you prove that the EDA will result in faster responses and real-time responses?
Well, I can prove.
But you will give arguments why this is the case.
Yes.
Okay.
Well, I would not give. I will give examples of what we did.
I'm looking forward.
Okay. So, in order to go towards that point, we propose to include in our event-driven service-oriented architecture the use of complex event processing. And complex event processing permits, by default, the processing and correlation of data very fast. So we could say that complex event processing indeed was designed in order to have real-time decisions, to provide real-time decisions based on the analysis on a stream of data that is currently received. And what we do is defining a set of event patterns. We would correlate the data coming into the system, so whenever the events reach the system and the pattern is detected, automatically an action or whatever is launched. The difference with other systems could be that we don't have to store the data, and this would be what will give us the fastness. So the advantages would be improved quality decision, and we can personalize service based on the patterns that are detected in the complex event processing engine. We can give, therefore, a rapid response. We also prevent information overload, because we are getting a lot of information in the stream, but we do not need to store it. We just need to process it, and once the situation of interest that we are interested on is detected, we can discard all the data. And we could reduce human effort in order to process all the data that is reaching and to detect the situation. Of course, our architecture could be based on enterprise service buses, or could be based on microservices or any other approaches, but we focus on these two. And again, we have advantages and drawbacks. So with the enterprise service bus, we will be able to integrate more easily different protocol communication, different applications. We can reduce the effort and the cost of introducing all these elements in our system and connecting all together. And on the other hand, with the microservice-based architecture, it will be easy to have all the elements decoupled and to provide all the communications loosely coupled, right, or mostly decoupled, like with the request response or publish subscribe. The deployment will be independent and we will be able to replace any of them at any time. But even though I will go back to this afterwards, I have to say that one of the problems that we found with the enterprise service bus is that it was not so quick. And it was very heavy and it consumed a lot of resources and therefore slowed down the system latency. So it's not quite convenient to integrate easily everything, but at the end we found that it was too heavy for the system. With the microservice-based architectures, we could have more scalability, evolution, and maintenance, and they are quicker. But at the same time, we know that we have more security points that could be attacked, or of course, we will have more data traffic between the different services. So it depends on the needs of the particular application. We can choose one or another. Okay. So where to deploy the services and to perform the data processing? Also was mentioned during the SummerSOC the options of entering into the cloud computing, fog computing, or edge computing. I'm not going to get deep into this because Javier probably will talk more about these topics. So the idea is, at the end, you need to balance the resource consumptions versus the communication costs. So the architecture you choose, it will depend on the needs that you have for this particular domain. And also, you have to balance greater awareness versus data privacy. So we are really looking forward to context-aware services and to context-aware information, but we also have to take into account that that information might be private and that the person interested on this data might not be allowed to see it. It depends. So we might have some e-health applications on the patient saying that he wants to keep her data, but it might be also that his health could be improved if we access such data. So we need to find a balance and to find agreements on this. And we of course can have hybrid architectures which use the different levels for processing data. So maybe the more private data can be processed in the edge, so it doesn't have to go out the domain, the scope of the end user. And nor so critical data can go to the fog computing area and be correlated with other data. And let's say no private data at all can go to the cloud and be used in other domains. Also mentioned by Harold, we have to make use of a kind of hierarchy, and we have to do an early filtering of data on the edge, not only because of avoiding the cost for the network, but also to keep the security and privacy of data. And I would like to bring your attention to some challenges we found in this scope. So first challenge is interoperability, that was also mentioned here. We propose, in order to deal with such interoperability problems, the technology that we have mentioned before. We have published some papers on that. And we have approached some software architectures that make use of such technologies. You cannot see too much here, and this is. Yeah. So what we have here is one of the first architecture we implemented for the context-aware service-oriented architecture. And it was based in an enterprise service bus, where it was integrated the complex event processing, so to make it possible to have the event-driven SOA. And we could obtain data from different domains, not only with publish subscribe, but also with request response mechanisms. We integrated different data with different protocols and formats and so on and so forth in order to process them and check based on the context of every person, because it was an air quality domain, based on the context of every person, meaning his, her age, any breathing respiratory problem, or the activity she was doing, like doing a sport outside or just not doing anything. So we adapted the notification or the alerts when the air quality could be bad for them, depending on such context in real time. Afterwards, we went for a collaborative Internet of Things scope. So we kept this enterprise service bus architecture up here in the cloud, and we reduced the resources needed by such architecture in order to deploy them in the fog. And what we did is simulating different event-driven source in a Raspberry Pi, like a cheap, as a cheap way of having them in different hospitals in order to check how many people is reaching with respiratory problems to the internet and also to the hospital, and correlating them with the air quality data. And at the end also we try to check how it would work in a microservice-based and predictive, including also prediction in the software architecture, and also combining the prediction with the complex event processing. So at the end, our main aim was in with different architectures in which were the options in order to process all such data fast with complex event processing and providing quick feedback to the user to improve their needs. We did some performance evaluation. I didn't put all the details here because we have a couple of papers on it. So most of our papers already includes some performance evaluation, but particularly we saw it was interesting, and it was you couldn't find many information in the literature. So we wrote a couple of papers specifically about performance. Of course, the performance completely depends on the final architecture you have. If you have an enterprise service base or microservice. And in the case of using complex event processing, it depends a lot on the pattern operations. So it is very dependent on the patterns that you really define in your use case. It's not the same that you have mathematical operations, or you have data windows, or you have time windows that may be kept along just an hour or 1 day or 3 days. It depends on all of that. It was difficult to compare to other proposals because, as it was already said here, most of the proposals that make some kind of evaluation on this do not provide enough details about the evaluation. We tried to provide a lot of detail, but give claim. I have to say that we provided almost everything that he said. We have to improve too. But at the end, in our papers, you can find normally which is the machine that has been used with which operating system. We provide a benchmark specifically for expert complex event processing. And as a medium, we saw that in this machine, particularly, it was easily reached 20,000 events per second.
Non-persistent messages.
Yes. Yes. Of course, with a low latency, right? But of course, as I said, it's very difficult to evaluate because it depends a lot on the patterns you use. So we are currently doing additional additional tests, because until now we did this kind of tests, and what we did is increasing the input rate to see where the limit of the system was. But we didn't check what would happen if you have very long windows. Like now we are working with an enterprise that is using in his patents windows of 2 days. So we don't know, once we have, in their case, 20,000 events per hour, that is their case, 20,000 events per hour, but that they need to be kept during 2 days in memory, we have to see what happens. We are currently evaluating that. So, second challenge, of course, is sustainability. It was already mentioned, the importance of sustainable development goals set by the United Nations. There are a lot of domains where we can apply this and others IoT technologies, like health, energy, water and sanitation, and so on and so forth. And we think we can provide a solution for some of them. In particular, we work on several case studies. Our first years we were working mainly on air quality. We of course worried about air quality because all the last years worries about how it could affect to life, and also because it is very related with the allergy symptoms. So if you combine both bad air quality and allergy symptoms, you can also have more health problems. So we work on these two topics. We could access to the air quality, to the sensors that the Andalusian government have all over the region, and we could work with them for a few years. And what we did is applying such architecture that we saw before that could be here, and we made it to interact with the mobile application so that any user could install it and integrate with his own context, his health issues, and his usual activities, or even the mobile phone could check if the user was running or was hiking or was doing something like that, and then select the kind of alerts that should be sent to him if the air quality gets bad. And we extended that in order to provide the collaboration of the citizen in an allergy application. So the citizen that we consider is really relevant for the collaborative Internet of Things could provide, that is in Spanish, could provide how he was feeling every day. So the decisions on how, I don't know if any of you have allergy. I do. I have allergy to some pollens. And the thing is that when you see the predictions of allergy, it's something like low, medium, high, right? But medium can be that you are okay, or can be that you are almost dying. And it's difficult to know, and I don't know if there is a scientific basis on why same apparently amounts of pollen can affect you different or make you have different symptoms. So we found useful that people in the same region and that is allergic to the same things as you provide which symptoms they are having. And then you are expected to have such same symptoms.
Do you key in your health situation? In the front end, do I key in my health situation and you make some recommendation what to do next?
If we make recommendation based on this? Yeah. Well, no. We send a message saying people around you that has the same allergy as you today is having eyes itch, for instance. And then
is the knowledge base exchangeable? Is it so? Because Bernard and I work together with the University of Crete on COPD. COPD is the lung.
Yeah, I know.
Right? I didn't know that most of the people, it's the most severe health situation because people die. And here in Crete, there is the group that is leading worldwide work on COPD. So I bring you in touch with them. They have a knowledge base to predict COPD and so on. So maybe you are, because you said you are looking for collaboration.
Yeah,
so
sure.
I was very eager. It's very nice application, I think.
Yeah, we try to work on COPD.
Yeah.
We applied for a couple of grants into the e-health system, but we didn't get it. But I think that the main problem is, of course, for COPD, I think the needs are completely different, because indeed what they need is to improve the exercise and so on and so forth.
Treatment.
Yeah, sure, treatment. Yes.
Treatment.
Yeah, but
So there's I worked together with the university and with the lung center here, and the people keep in their current health state over a couple of days, and they have a knowledge base to predict seeing a doctor, because it's very important, because people are living far away from the city here in Crete, and they just getting a hint, see a doctor because you are in a severe situation, is extremely helpful.
Yep.
Not only Crete, worldwide. Very interesting.
Thanks. So another topic we were working on is about the problem of rubbish collection. Probably in other countries it doesn't happen, but in Spain it happens, right? So it's quite easy that you go to throw away your rubbish and you find that the container is full. And even though it seems that it's so easy to solve this, most of town halls do not do it. So we know a town nearby the university that are working on this, and the idea, the solution, what we did is building a prototype, and with just to check, it's so simple, just to check the level of the rubbish and how high or low it is. Of course, also the temperature in case of the fire or if the door of the container is blocked. But at the end, what we have is to know in real time how full is the container, if they should go or not to collect it. So this city next to the university are not using this prototype, but they're on. We have some conversation with them, and it's working perfectly with them. I'm unlucky, and I live in a city that they are not doing this, so most of the time the containers are full, and this is it. They don't have money for more, I guess. And finally, this is the project where what we have been working in the last year. So we are working with an enterprise of water management. And what we did is reducing the size of the architecture. So we are currently using the complex event processing with a message broker, right? The message broker is receiving all the data from this water company, and we are processing all the data in order to detect leaks, frauds, or maybe only to monitor the consumption. So apparently they have almost 30% of the water that is used is because of leaks. So it would be really useful.
30%.
30%, it's a lot. And also because some people know that they have a leak, but they don't spend the money on fixing it. But for them, for this enterprise, it's very useful in order to try to find not only the leaks, but also the frauds, because some people take illegally the water from there. So we deploy this architecture for them, and they are currently using them, and are really quite happy. And also we provided a tool that we have in the team that was developed by one older PhD student. That is, its purpose is to provide a graphical way of defining the complex event processing patterns, so that the people in the water management company can draw the patterns that they want to detect. And they have the knowledge of the domain, but they don't know how to program it. So the idea is that they try to draw the pattern, and then with some of our help to deploy it in the system. This last project was also done together with other companies, and is currently being finalized, and all these other companies are enriching such data and such situations that we are detecting. When we detect any of the patterns relevant for the company, and they enrich them with additional contextual data and natural language processing. And the idea at the end is that this company provides an APP with relevant information for the users, and not only for the users, but also for the workers of the company in case there is something that has to be fixed and so on, or checked. The following project that we hope to start soon is also with these same companies, and it's focused on spillways. So we live next to the sea, and as I said, Cádiz is one of the eldest cities in Europe, and so the pipelines are. So still, some of the main pipelines of some of these towns around the sea can throw the dirty water to the sea. Of course, this is controlled by the government because it's not expected to be done, and it is not usually done. But when it rains a lot, in the case that there is a risk of flood in the cities, they need to throw some water away. But the government wants to have a real report of what is happening in real time to know when it happens and if it should be happening or not. And the idea of what we will be doing in the project is correlating several data from several sources. Like it will be important to take into account which is the salinity of the water in the spillway, because what it happens to is that when the tiles go up, the water of the sea gets into the spillways. So even though you can see the water going out, the spillway is just clean water, it's water from the sea. But it's difficult to differentiate. So we will have to take into account the salinity, the tides, of course the wind, the rain, and other issues that are sensors that we have. This will start from September. And this...
Could we go 2 slides back? Because I think that's like one more. For this system, because as far as I understand, you have it, the company is using it now, and I'm curious what size of network this system is raising, and how many sensors do you have there?
They don't have that much yet, because this was the proof of concept of the project. So they started the project, I think it was with like 200 smart meters. But the plan is, because they need money to put the smart meters in all the houses on the industry, right? And they don't have so much money. So the idea is to put all around the city. The city they currently have around, we calculated 20,000 smart meters.
So the sensors are actually smart meters installed on the customers?
Yeah.
Okay.
Yeah.
Not on the pipes or somewhere?
They also plan to do something on that, but currently, as far as I know, they have also in the connection of the big pipes to the different zones. They have some sensor there. And they have the smart meters, but I'm not sure that they have in the other pipes.
Because I know that in the water management community, because the sensors are so expensive, and there are not even reliable, let's say, representations with digital twins or things that the researchers could play with, and the data sets are very limited.
Okay.
But I think that if you start going in that direction, it would probably be a good idea to discuss offline and probably to give a few contexts of people from that community who may actually be very, very interested in collaboration on this.
Thanks. Yeah. Okay. Let's see.
First, we dropped it out. Should we get something from somebody? Luca?
No, it's
Okay.
fine. Thanks. Okay. So we went for challenge 1, interoperability, challenge 2, sustainability, and challenge 3, collaboration and data democratization. We found several handicap and open issues that can be interesting for the community to research on, maybe some new PhD students. First of all, we found difficult combining multiple people and entities to share their data. It's difficult that even though most companies and people is starting to share data, it's still difficult to access to many of them, right? We also found that it's very important to make research on ensuring data security and privacy. It's complicated to find where is the limit for that. And I'll give you an example. This company that we are working with on the water management, water supply management networks, a couple of years ago, wanted to just make a little test on how these smart meters worked. And they put the smart meters in the houses, with their consent, in the houses of some of the workers of the company. Just for seeing if it works well and to see how many water they consume and so on and so forth. And they found out that one of the person working in the company went to the toilet several times at night, and they found out that they have an illness. So at the end, something as simple as the water that you are consuming can be into your privacy data. So it's difficult to find out which data could be shared without risk or could not be shared. Also, another handicap is providing the means to facilitate different source data interoperability. We expect, as we will see in the following slides, to be able to make use of data from other domains that have no relation apparently with the main domain of our application in order to improve the context. And it's difficult to integrate the data from different domains, not only because of such differences between domains, but also because of the format and the way they are provided and all the description of the data. Also, we found an interesting approach to do research on providing a framework to facilitate the correlation and contextualization of data, as I said, from several domains. That is what I'm going to propose later on, and has a lot of relation to what Boris mentioned the first day. In fact, he was talking about data friction, trust, catalog, privacy, and I found all that very related to what I'm presenting now. So what do we mean with using data from other domains into a completely different domain? Maybe I'm going to give you some very simple examples. So water consumption or electricity consumption in a house, we can think about, I don't know, something broken, we can think about a fire, but they can be used for other things. So we can have a lot of applications, for example, in the ambient assisted living domain. So if somebody is not opening the tap along a full day, and here she's living alone, maybe she should receive a phone call to see if he's okay. Or even more, maybe if he's not using water, neither electricity, maybe something happened and somebody should call emergency or something like that. It happens so often that these people that live alone are abandoned for days because nobody knew that something happened, and it's so easy to see just if they had any consumption to see if they can be okay or not. Another example would be, for instance, that some person that is maybe also living alone or not, never mind, is going to throw the rubbish away. And this person, if we have some sensors in the bin, and such person may have an application from the bin council installed, we can see if she goes to her usual bin or goes to a different one. What may have happened if she goes to a different one? Well, it may have happened that she is an old person that got disoriented and does not find a way to go back home because he went to a completely different place without realizing, and we could check that. Or it could happen also that the bin was full and then we should advise the rubbish collection company in order to check why is it full. Maybe the sensors that they have in the bin are not working properly, providing the information about how full it is. So we can correlate something completely from different domains, that is what the person is doing, that is just throwing away the rubbish, with this other information to see if he has any health problems or maybe if the sensors in the rubbish bin are not working properly. So this is a very simple example, but it can be extended to many other domains. So information from different domains can be very useful for both domains, because in those completely different situations, we are benefiting the person and we are benefiting the rubbish collection company. What we propose to do is, first of all, to define a taxonomy for smart everything, because we couldn't find proper definitions that can be applied to several domains, but at the same time that are not so simple as to have to work a lot on it. So we did a research on we studied many other proposals, and we tried to find the most common attributes that should be found in this taxonomy. So we are working on a paper on that now, and we provided a taxonomy with what we think is really relevant in the scope of IoT and smart everything. Besides, we expect to provide, or we define, a common JSON structure based on this taxonomy, with the idea that the different companies can share their data using such JSON structure, which can be ambitious, but otherwise they can provide the data in a different format, and then we can provide a transformer to have the data in the JSON structure. And finally, such JSON should be processed by the complex event processing engine, and we can also have the actions that can also be defined in taxonomy. So in the taxonomy, we can define what we want to detect and what we want to do when it is detected, and to combine everything together in the software architecture.
Look, you build the taxonomy for certain domains. You can't build that. No, you can't build all the taxonomy for all smart.
We try to build a taxonomy that could be reused.
Everything?
Of course not.
Okay.
The idea is the very common things.
Yeah, yes.
The very common things, and then it is extensible to whatever is needed in different domains.
So, and different domain experts can extend the taxonomy.
Yeah.
This is absolutely good.
So this is our work in progress framework, and I should be finishing, I guess. This is would be the SEP engine, and we decided, of course, we have two databases, one for the persistent context and one for the actions, where we have in the persistent context what we have in the context that we know in advance. For instance, the people that is living alone and have some mental issue, right? And also the actions that we know in advance that we want to take when a situation is detected, like calling the person that is taking care of her. We have three types of events: the proper from the domain, so for instance, water consumption or going to throw the rubbish away; the local context events, that are those of this domain that can be shared for other domains, like the person is delivering the rubbish in a different container, and we can share this with the rubbish collection company; and the remote context events, that are those which are completely decoupled from any domain, like, let's say, the weather forecast, to simplify. And we plan to have a catalog of topics where we send all this data, and that can be reused by other domains. So we send the local context events, and the remote context event can be obtained from the catalog and sent to the SEP engine. And also the situations already detected by the SEP engine can feedback the system as new events known. So for instance, if we have this, the person that is taking the rubbish to throw it away, would be this domain event. And then we have the local context event that she throw it away in a different container. And this event feedback the system so that other companies can use them. And then we check that the person had mental illness, and then maybe she is lost and should call the care person, or maybe the problem was that it was full, and then we should contact the company of the rubbish collection. Well, this could be the remote context events that could be used also in other domains. And I would just would like to add 3 comments that were done here. We have to make use, as I said before, of a hierarchy and early filtering. Edge is heterogeneous indeed, and this is a difficulty in order to mix up the data from different domains. And we also need to do some real-time learning from smaller data. It's not only a question of big data, but smaller data such as a person throwing away the rubbish can be important in different domains. So coming to conclusion, we expect to give one step forward towards context-aware smart everything. We have, of course, endless case studies where we could apply these technologies and this application. And at the end, not only using, as I said, big data, but smaller data, data from every person that can be interesting for them, and using the context of different from different domains all together with the big data and small data, and improving the collaboration of the different entities of the society in order to share their data. With all this information and the software architecture, we might have more sustainable cities and society in which we live. I would like again to highlight the open issues that I foresee, like data privacy and security, data format standardization. There are some initiatives so that there is not yet a common agreement on how to share the data from IoT and smart everything. Improving data sharing and democratization, and of course systems and data interoperability. And I also found very interesting the talk from yesterday that we also see how to develop our software to be more sustainable. It's also a very important thing to think about now. And this is all. Thank you very much.
Questions? So I think you the microphone.
No, it's fine. So one question, do you have a language to define context? You know what I mean?
Yeah.
First of all, what is context? And do you have a language that people can specify their context?
No, that's the idea. That's one of the objectives of Adrian PhD, right? It's there. And we are first defining the taxonomy, and the idea is that the taxonomy is not only useful for the domain events, but also for the context domains, because at the end are the same thing, but from different domains.
And in the past there was work to derive situations out of context.
Yes.
You're aware of this?
Repeat.
You had some examples, container, you had some examples, the container is full, and there was a person who was sick and so on, and then you derive he's lost and so on. This is, you have context and you derive out of the context situations.
Yes.
There's also some work going on, maybe you take a look at it, that the situation awareness could help you in contrast to context awareness.
Yep.
That was only right there.
Thanks.
Bernard and I and others, and this time already read, we had a huge project on that.
Yeah, thank you.
Thank you.
Next questions? Yeah. Just a minute.
Just to you, Martin. No question.
So we did some work on context awareness some 15 years ago or so.
Yeah.
Sorry.
No, but this could be really helpful because we, for example, developed the concept of context tunneling, basically to tunnel specific context information from one application to the other. That could be maybe useful for
Which is a privacy problem.
Yes, but that can be dealt with.
Okay, thanks.
about critical infrastructure, so water management, waste management. And it's also interesting to see the interrelationship between them. So for instance, the water network is related to the energy network, which is related to the transport network. So are you looking also into how the data of one affects the data of the others and vice versa?
No, not yet. We want to do work on that. But we are 5 persons, as I said.
That's everything. So you miss smart grids and then infrastructure, so that's good data.
I completely agree. The thing is that in real life, right, we didn't manage to have the whole data altogether. So until now we have access to the water sanitation data, and we expect to have access to other data in the future.
Other questions? One from and then you ask a question. You got other questions? Yeah.
It's a super interesting topic, and my question goes in the same direction, but a little different. You see, there was a lot of discussion in the past on how you can actually synchronize on the protocols. For instance, there is this famous ZAREF ontology funded by the EU 10 years ago or something like this, but that was more on a protocol level, you know? And now we are talking the semantics level, which is far more complicated. How do you feel? Is that actually possible to standardize this in the close future, or would you say to this question that that's what we dream all about, but it doesn't work? I mean, like, what do you feel? What steps are required to actually get this smart everything somehow standardized?
Well, of course, the semantic agreement is complicated, and we also checked other system ontologies. And I would say that I would say that the semantic agreement is complicated, but maybe we need natural language to understand everything. So our idea is that if you have a catalog, in the catalog you can see the data and maybe a description of the data that is provided by every user as context data. But our aim is that the data is shared in such a format, but then it can be accompanied by a description that may other companies to be able to understand it. So it's not expected that automatically it can be ingested by any system, but if you want to make use of this data, then you can see how it is and you can inject it in your system. I don't know if I answered your question.
Other questions or coffee? Coffee. So thanks for the again. And we see you at 4. So